Gelatin is a sweet and silky ingredient produced from collagen extracted from animal bones and skins. Its delicious flavor makes desserts even tastier. But how is gelatin produced on an industrial scale? In this video, we will uncover the untold story of gelatin. Gelatin was originally developed by American inventor Peter Cooper in 1845. His invention solved the problem of food preservation before the refrigeration era, allowing the creation of products with a longer shelf life that helped preserve perishable ingredients. This invention was especially valuable during World War I and World War II, providing soldiers with a protein source that was easy to store and transport, used in military rations to feed the troops. Over time, gelatin also became a key component in the manufacturing of medicine capsules, making them easier to store and consume. Additionally, it enabled the creation of desserts and products with innovative textures, enhancing ingredient versatility and offering easy-to-prepare options. Gelatin is a protein substance derived from animal collagen, mainly extracted from the skin and bones of pigs and cows. It is colorless and soluble in hot water, forming a semi-solid, elastic texture when cooled. It is used in the food industry to make desserts, candies, and meat products. Its gelling and stabilizing properties make it a key ingredient in the production of various foods and nutritional supplements. But how is gelatin made in a factory? The production of gelatin begins in meat processing plants, where raw materials with high collagen content are meticulously selected. These raw materials mainly come from pigs and cows, whose bones, skins, and connective tissues are rich in this valuable protein. When the animals are slaughtered, meat cuts intended for human consumption are carefully separated, while collagen-rich parts, such as bones and skins, are collected for further processing. These essential raw materials are transported in refrigerated trucks to specialized gelatin production plants, where they are kept under strict temperature controls to prevent decomposition and ensure maximum product quality. This factory receives a delivery of 5 tons of skins and bones every day. Upon arrival at the factory, the bones and skins undergo a meticulous cleaning process to remove any impurities, fat residues, and meat remnants. This step is crucial, as the purity of the extracted collagen depends on the total removal of contaminants that could affect the texture, color, and flavor of the gelatin. Washing systems with water and special solutions are used to dissolve impurities without damaging the collagen structure. The gelatin factory is one of the largest in the world. It can produce more than 10,000 bags of gelatin powder per day, which are then distributed to the market. The plant consists of enormous stainless steel containers interconnected through an intricate network of pipes and conduits. This sterile environment prevents contamination and allows precise regulation of key factors such as temperature, pH, and concentration, ensuring optimal production. Once the materials have been sanitized, they undergo a size reduction process to facilitate the following extraction phases. The bones, which are particularly hard and dense, are introduced into powerful industrial crushers that break them into uniform fragments of approximately 2 centimeters. This size allows better penetration of chemical and thermal agents in later stages, maximizing extraction efficiency. Meanwhile, the skins are cut into thin strips using high-precision blades, increasing their surface area and allowing chemical compounds to penetrate each fiber uniformly, accelerating collagen release. Once reduced to their ideal size, the skins and bones are submerged in enormous tanks of hot water at a temperature of 70 degrees Celsius. This thermal treatment serves a dual purpose. It helps dissolve collagen fibers and breaks the molecular bonds that hold them together, releasing a protein-rich liquid solution. The temperature must be precise, as excessive heat could degrade collagen quality, while insufficient heat would slow down the extraction process. To improve collagen solubility in the solution, an acidifying agent, usually vinegar, is introduced. This step is essential as acids modify the collagen structure, making it more extractable and processable. The collagen extraction process continues with a cooking phase, where animal tissues are subjected to carefully regulated temperatures to ensure maximum collagen dissolution in water. This procedure, which can last several hours, progressively breaks down the fibers, releasing their structural proteins without degrading them. Cooking temperature and time must remain within optimal ranges, as excessive heating could alter collagen quality, while insufficient cooking would limit its extraction. As collagen dissolves, a viscous and dense solution similar to a concentrated broth forms, containing various soluble proteins and other organic compounds. However, at this initial stage, the liquid still has significant turbidity due to the presence of solid residues and undissolved particles. At this point, the solution enters a purification phase to remove any residual impurities. To purify this solution and obtain a more refined product, it undergoes a rigorous filtration process. Filtration is crucial to ensure the transparency of the gelatin in the factory. This stage is carried out using ultra-precise ceramic microfilters. Under enormous pressure, the solution passes through filters with microscopic pores that are imperceptible to the naked eye, resulting in a completely clear and purified liquid. The result is a clean, homogeneous collagen broth that serves as the liquid base for gelatin. In total, the filtration process runs through approximately 3,000 meters of pipes. Despite this meticulous process, some dissolved salt residues remain in the solution, as well as a high water content. To remove these elements, the mixture passes through large containers filled with tiny synthetic resin spheres that attract and retain salts. Next, the collagen solution is pumped through extensive stainless steel pipelines and undergoes an evaporation process in large tanks until a dense, viscous concentrate with a honey-like consistency is obtained. This phase, known as concentration, significantly reduces the solution's volume. For every 2 liters of collagen solution, only about 200 milliliters of concentrate remain. To ensure its stability and microbiological safety, the gelatin undergoes brief heating, eliminating any possible residual microorganisms. Then, the concentrated liquid is slowly cooled. As it cools, collagen transforms into a semi-solid, elastic gelatin. The concentrate is pressed through a perforated disc, forming the characteristic gelatin noodles. These filaments fall onto a conveyor belt where they are progressively dried. During this process, sterile hot air evaporates the remaining moisture. Then, the fully dried gelatin strands are ground into a fine powder. Once the gelatin has been dried and turned into powder, it is mixed with other ingredients to add flavor, color, and improve its texture. First, sugar is added to provide the necessary sweetness to enhance the flavor and ensure product stability. pH-regulating acids, such as citric acid, are used. Flavorings create a wide variety of flavors, such as strawberry, lemon, or orange. Additionally, colorants are incorporated, which can be natural, like beet extract or turmeric, or artificial. Finally, stabilizers and anti-caking agents are added to prevent the powder from clumping inside the packaging, ensuring ease of use and preservation. It is then stored in large bags with a capacity of up to 1,000 kilograms. This is how gelatin powder is made in the factory. Give this video a like if you enjoyed it and share it with someone who might be interested. Also, subscribe to this channel and turn on notifications to keep learning.